The concepts of matter in physics. Concepts of matter. Matter. What exactly do we mean by matter? See, by matter is anything that has mass and occupies space. Even a granule of chalk is a matter because it has mass. It occupies a space, that means it has volume. So things like these, myself, I am a matter, you, everything is considered matter. Okay, now, there are many states, but at our level, we shall consider only 3 states. See, the 3 states of matter. Physics states of matter. 3 physics states of matter. 3 physics states of matter. These are 1. Solid. 2, we have liquid. And 3, we have the gas. These are the 3 states we are considering. There are other states, but what our syllabus requires is what I've put on the board. Okay, now, any state at all is made up of particles, which we refer to as molecules. So over here, we are going to look into solid differently. We are going to look at the liquid. We are going to look at the gas. Any matter at all any matter is made up of particles, which we refer to as molecules. Okay. In solid, how do they appear? In solid, they are tightly packed. Very tightly packed. And what happens to them? They vibrate, about their mean position. They vibrate about their mean position. What do I mean by that? If any particle is at rest, it could only be at rest when there is no energy in the body. We have the molecules arranged orderly like this. We have them like that. And what happens is that each of these molecules exert force. The force could be that of attraction. It could be that of what? Repulsion. So attraction, repulsion could make it to be what? To be vibrating about the mean position. These are the mean position, where the position of rest. We can refer to it as the position of equilibrium too. These intermolecular forces act on each of these particles, depending upon the form, attraction or repulsion. Attraction could happen if they are oppositely charged, and repulsion could happen if they carry the charge of the same word, of the same nature. Positive to positive will result in repulsion, negative repulsion, negative positive will result in attraction. So with these different forces acting on each of these molecules, it brings about vibration. So they all vibrate about their mean position. And I said the mean position could be referred to as position of equilibrium or position of rest. So they move. If this is the resting position, then they will be moving like this. But the movement also depends on what? Depends upon the temperature of the body. Now, they are tightly packed. They vibrate about their mean position. That is true. The rate of vibration, like I said, depends on the temperature of the body. As the temperature increases, the amplitude of vibration becomes larger and larger. This will lead us into another topic. In solid material, the intermolecular bond is very, very strong. The intermolecular bond is very strong. 3, the intermolecular bond, is very strong. 4 is solid. A matter in solid state has definite shape. Definite shape. Five, if it has definite shape, then it has definite volume. Okay, these are the characteristics of the matter solid. We can also look into the liquid state. So in liquid, the molecules are equally, the molecules are equally, closely packed, but not as it is in solid state, as it is in solid state. That is one. Two, the molecules also vibrate. That is, they move freely with the molecules sliding over one another. They don't have definite shape. They take the shape. That's liquids. They take the shape of their containers. These are the three major characteristics of liquids. In gas, the molecules are widely apart. Two, they move freely in their container. Three, they take the shape of their container containers. Four, they are compressible The molecules collide with one another. The molecules collide with one another. And okay, let's put it this way. VI. They bombard the walls of their containers. Exerting pressure, Okay. Now, these can be shown experimentally the evidence that these things called matter are made up of what? Of molecules. And we can equally use the kinetic theory to explain these. To establish or give an evidence of the existence of molecules, we use what we refer to as Brownian motion. So, evidence of particle nature of matter. Evidence of particle nature, particle nature of matter. You see, the evidence could be shown using the method we refer to as Brownian motion. See, a British scientist called Brown, he developed these, and it was named after him, the Brownian motion. What exactly did he do? He collected some smoke particles into a container, a transparent container. And so he used a microscope to monitor the particles here. And a powerful beam of light is directed to this container. At the top, we have the microscope to monitor the behavior of the particles of the smoke. We have to bear in mind that we cannot see the molecules, but we should also have in mind the particles of the smoke are lifeless. They can move on their own. But with the aid of the microscope, you see that the particles are moving. Then the question arises, what makes them to be moving? It is the molecules of the air inside the container that are moving about, that are colliding with these particles of the smoke from various angles. So you see the particles just vibrating in different directions. That tells us that in the air, which is a gas, in gas form, we have particles, the molecules, which are in continual motion. And as they move, they collide with every object in their way. The smoke particle is the object in their way. So if the smoke particle looks like this, you see you have the molecules bombarding it from various angles. And so you see it jostling, okay, moving, shaking, as if there is life in it. That is an evidence that at least a matter is made up of molecules. I hope that is understood. Now, we can also use the kinetic theory. What does the kinetic theory say? Using the kinetic theory, to explain the evidence that to explain the evidence of the particle nature, of the particle nature. Of matter. Kinetic theory simply states that, first of all, let's look at this word, kinetic. It has to do with what? Motion. Kinetic has to do with what? Motion. So the theory propounded using the motion form, using motion to tell us the particle nature of matter, is that it states clearly that it is only when a body, which is a matter, rises above the temperature minus 273 degrees Celsius, that the particles in a solid material or in matter will be doing what? We begin to move. In solid, they vibrate. In liquid, they move, they vibrate, and at the same time, too, they slide over one another. At these temperatures, minus 273, the energy required for them to move is completely what? Lost. And therefore, there will be no what? No motion. But anything above this, anything above minus 273, example, minus 272, minus 271, minus 270, down to 0 degrees Celsius, to 1 degree Celsius, 2 degrees Celsius, the particles will be what? Will be moving. Will be energetic enough to do what? To move. That is what the kinetic theory tells us. And in fact, by the time we get into the gas, if we are lucky, then we shall see, when we investigate the gaseous state properly, we will be able to plot a graph to show that if the graph is interpolated or extrapolated, it will cause the axis of temperature at minus 273, where all energy is completely what? Lost. So it's simply, the kinetic theory tells us that there is particle in every matter. These particles move. The moment the temperature of a body goes beyond minus 273 degrees Celsius, they will go in various forms of motion depending upon the what? The state of the matter. If it is solid, the molecules will be vibrating about their mean position. If it is water, it will do similar thing, but it could also slide over one another, moving freely. Okay? Now, if it is in a gaseous state, the molecules are in continual motion. They move from one place to the other, moving randomly, colliding with one another, and bombarding the walls of its container that ends there.